Okay. Okay, today we're going to look at tangents to a curve. A tangent is a straight line, and I like to think of a ruler up against a basketball. You know, a basketball is kind of curved, and you take the ruler and you put it up next to the basketball, and you look at it, and it goes, whoa, it looks like it just about touches in one point when you have a curve. Well, that's kind of what a tangent line is. It's a straight line that just touches at one point. Whenever they say find the equation of a tangent line, you have to use the equation of a line formula. Y minus y1 equals m times x minus x1. And we get gradients by finding the derivative. If you have a function, if you go f prime of x, it'll tell you the derivative at any x value. Okay, let's look at a function here. We got f of x equals 3x squared minus 6. And we want to find the equation of the tangent right at x equals 1. Well, we've got x equals 1. If we're going to find the equation, we better find what the y value is. So you take 1 and you put it in the function, 3 times 1 squared minus 6, and you get minus 3. So we have what's called the point of tangency. I've never used that word before. I like it. The point of tangency is 1 and minus 3. But what's the gradient at x equals 1? Well, all we do is find the derivative. 2 times 3 is 6x. The derivative of minus 6 is 0, so it's just 6x. Well, if we take 1 and we put it in the derivative formula, we get the gradient right there. Well, now we've got everything we need. We've got the gradient, we've got a point, which is 1 and minus 3, and we just put it in the formula. Y minus minus 3 is y plus 3 times m, which is 6, times x minus x1, which is 1. Then we just multiply it out. 6 times x is 6x. 6 times minus 1 is minus 6. We subtract 3, and we go minus 6, minus 3, and we get minus 9. A little bit of a typo there. So the equation of the line is y equals 6x minus 9. Now let's take a look at this one. Okay. You've got f of x equals minus 3x squared plus 3x, and you're asked to find the equation of the tangent, which is parallel to y equals x plus 2. Parallel to a line that has a gradient of 1. Okay. Well, the deal is, it says y equals x plus 1. I think it's supposed to be plus 2. That line has a gradient of 1. That's the key. We can see that because the number in front of x is always the gradient when it's in this form, y equals mx plus c. So we know the gradient right there. We actually need to find the gradient at the point that makes a gradient of 1. So what we do is we find the derivative of the function, which is minus 2x plus 3, 2 times minus 1, 1 times 3. There's the derivative. We want to find out which x value will make that 1. So we take the derivative, minus 2x plus 3, let it equal 1. Then we subtract 3, we get minus 2. We divide by minus 2. X equals 1 is exactly the point where the derivative's 1. Okay, then all we need now, we've got the gradient of 1. We've got the x value is 1. We need to find the y value. We don't put it into the derivative. We got to put it right back into the original function. So minus 1 squared plus 3 times 1, minus 1 squared, we put it back into the original function. The value of the function at 1, minus 1 plus 3 is 2. So the point is 1 and 2. The gradient is 1 because it's parallel to that line up there, y equals x plus 2. Well, there we're going to get it. There goes in the gradient. There's x minus x1, y minus y1. 1 times x, we get minus 1. We add 2 to minus 1, we get plus 1. There's the equation of the line at the point of tangency, which is 1 and 2. Okay, there's a couple of questions done. And I think that's about it for now. So I'll stop recording now. Okay.